In this video, I'm just going to show you another polynomial equation that you'd be asked to solve. So I believe this one comes from the practice problems. It's number 4. So x to the fourth plus 6x cubed plus 2x squared minus 26x plus 17. Alright, so we're trying to find all the x values that would make this equation equal 0. So we're going to start by doing the rational root theorem. So p is 17. Which is great. Any prime number is awesome for the rational roots theorem because very limited number of roots. And q is 1. Also another awesome number to have for rational root theorem. So when you put every p divided by every q, it gives us a very small list. 1 divided by 1 is just going to be 1. And 17 divided by 1 is just going to be 17. So from here, you're going to use your graphing calculator, graph the original function, and know that if there are any rational roots for this problem, this polynomial, which again we would need rational roots to be able to use synthetic division, that it's only going to be at 1 or -1 or 17 and -17. So when you graph this, the only place where you see it touch the x-axis is at 1, and it does that business where it just touches the x-axis like this. Okay, and then you have the rest of the graph going on around it, but that touching the x-axis is really important. What that means is that that root has a multiplicity of 2, so you can kind of think of it as a double root, which means you have to use that number, the number 1, twice in synthetic division. So we're going to start off by using 1 for synthetic division. We're going to use the coefficients from the original problem. So 1, 6, 2, -26, and 17. Another way you can kind of tell you're going to have to use synthetic division twice on this problem is your original equation or your original polynomial is an x to the fourth. And typically you use synthetic division enough times to get what's left over to be an x squared equation. And since each time you use synthetic division, you can only decrease the power by 1. That tells you in order to get to an x from an x to the fourth to an x to the second, you're going to have to do it 2 times. So we're going to start this first time, bring down the 1, and then we multiply 1 times 1, going to give us 1, and then we add them down. So 6 plus 1 is 7, and then we repeat. 1 times 7 is 7, add them down, so you get 9. 1 times 9 is 9. Add them down, you get -17. And then 1 and -17 make a -17, remainder of 0. We use synthetic division one more time, and to be efficient, I just kind of tack on to what we have here, so I don't have to recopy those numbers, because the numbers that are underneath the line are the ones we're going to use for synthetic division the second time around. And here we go. Bring down the 1. 1 and 1 multiplied together gives you 1. 1 plus 7 is 8. Multiply, you get 8. Add them down, you get 17. And last but not least, 1 times -17, or excuse me, 1 times +17 gives you +17. Add those 2 down, you get 0. So what we're left with is a 1x squared plus 8x plus 17 is equal to 0. Now you might be wondering, on another polynomial that's an x to the fourth, what happens if it has 2 different roots where it crosses the x-axis. So say for example, I think number 1 from the practice problems, it crosses at +1/2 and +5. So you'll have to use +1/2 and +5 for synthetic division. It does not matter which one you choose to use first. And if you don't believe me, try it both ways. Try it with the 5 first and then the 1/2, and then vice versa with the 1/2 first and then the 5 second. And you'll find that you'll get the same numbers across the bottom here, no matter which way you do it. So now all that's left over is to solve what's left here. So the x squared plus 8x plus 17. What's nice about this, we don't have to factor anything out. So you can either use the quadratic formula or complete the square. And I'm going to use complete the square because this is a perfect place to do it. Alright, so we'll complete the square. We're going to start by moving over the constant term. putting a square in its place. And then on the other side, putting a square as well. We're going to take half of the middle term, so positive 8 divided in half is positive 4, squared in the box. Same thing on the right side. And then we have x plus 4, the quantity squared, is equal to, on the right side, we have negative 17 plus 16, so just a negative 1. From here we can go ahead and square root both sides. So x plus 4 is equal to, now over here we're going to have plus or minus. You can bring out the negative, so it looks like I square root of 1, and then the square root of 1 is just 1, so it's really kind of plus or minus 1i, and we really don't need to put that 1, so I'm just going to write plus or minus I, and then last but not least, move over that 4. Alright, so since we ended up with an I in our solution there, that goes with what we saw in the graph. We didn't see the graph cross the x-axis at all if you're in a standard window. It just touched at 1, so it makes sense that the other two roots are imaginary. And then x equals 1, it has a multiplicity of 2, or you can kind of think of it, like I said, as a double root. So that counts as two roots. Negative 4 plus I, negative 4 minus I count as your other two. So there are your 4 roots for that x to the 4th polynomial.
Made with Doodlecast Pro.